Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to continue talking about solving radical equations. And sometimes the equations aren't going to have radicals at all. Sometimes they're going to contain fractions or rational exponents, okay, instead of the radicals. But we already know how to convert from a rational exponent into a radical, so it's going to be pretty easy. The steps are pretty much the same. You want to isolate the variable with the radical exponent, kind of like before you want to isolate the radical. Number two, now you're going to raise each side of the equation to the reciprocal of the given power, okay? Sometimes teachers teach you to go ahead and convert it back into a radical. You could do it either way. I'm going to show you how to do it both ways, but this is the easiest of the two ways. For example, okay, let's solve each equation. First of all, good job. You're going to divide by 3. Excellent. No, that was beautiful. Well done. So now I've got x plus 1 to the 2/3 equals 4. Now, you have two choices here, okay? The easiest and obvious choice would be to literally raise both sides to the 3/2 power. You want to multiply it to by the reciprocal. Why? Because a fraction times a reciprocal times its reciprocal equals 1. Very good, my brother. So I want to try to cancel this out. So then these two guys go bye-bye. 2/3 times 3/2 go bye-bye. And again, why are you multiplying them, Morrow? Because what happens is when you raise a power to a power, you multiply the exponents. So now I have x plus 1 equals. Now here you can actually go ahead and convert it into a radical. This is the square root of 4 cubed. All right? Does that make sense so far? Okay. So then I have x plus 1 equals. Now here we're going to separate the a's from the b's. What's the square root of 4? What's the square root of 4? 2. Very good. What's the square root of 4? 2. 2 cubed?
64.
Okay, so let's try this again, guys. What's the square root of 4? And what is 2 cubed? 8. Very good. However, it's plus or minus 8. Why is it plus or minus 8? Because it's a square root. Whenever I have to square both sides, okay, when I have a square root here, it's going to be plus or minus. All right. So now I have x equals 8 minus 1, and I also have x equals negative 8 minus 1. So x equals 7 or negative 9. Yes, sir.
Does the plus or minus rule apply if it's
Come again, if you cube it? No. No, sir. No, sir, not at all. And actually, now that I'm thinking about this, when I do the extraneous here, negative 9 isn't going to work. Because negative 9 plus 1 is negative 8, right? And the cube root of negative 8 is negative 2. Oh no, negative 2 squared is 4. 4, yeah, that works. So it is a plus or minus. So my answer is x equals 7 and negative 9. Okay? Now, there's another way to do this. You could, from the beginning, go ahead and do as follows. You got x plus 1 to the 2/3 equals 4. Now you can make this the cube root of x plus 1 equals 4. And actually, you know what? I was wrong. You don't have to do plus or minus. And this way, this is squared. Yeah, you're going to have to do it eventually. Yeah, I was right. Okay, good. So I have the cube root of x plus 1 squared if you so choose to prefer this way. How do I get rid of a power, an index of 3? You cube both sides. So when I cube both sides, this is x plus 1 squared equals 64. Square root both sides, you've got x plus 1 equals now plus or minus 8. And then x will equal 8 minus 1, and x will equal negative 8 minus 1. So x will equal 7 or negative 9. So either way, you're going to get the same answer. If you convert it to a radical form, a lot of my students see it a lot easier. Oh, I had to square root both sides. I had to get a plus or minus. If you don't do it that way, you do it the other form, you have to always pay attention to that. If I have a square root and I find the value of square root, it's going to be plus or minus. Actually, it's to any even root. Okay, letter B, what do you think I do? Yeah, you subtract the 3. Excellent, gentlemen. So I have 5x minus 1 to the 1/2. It's not squared. It's not squared. It's to the 1/2. And that equals 10. Now, how do I cancel a power of 1/2? Now, you raise everything to the second power. Maybe I should learn how to add. Thank you, gentlemen. This is 7. Actually, you are adding because you add positive or negative numbers. Everything is in addition, but thank you. So I've got 5x minus 1 equals 49. Add the 1. So 5x equals 50. So x equals 10. I did not have to do plus or minus here because I didn't have to square root anything. I squared something, but I did not have to square root anything. Okay? Okay, how about C? How would that work? What do I do first? Yeah, very good, my brothers. You add the 7. So I've got 2x minus 3 to the 1/3 power equals 3. How do I get rid of that 1/3 power? You cube it. Very good. You don't multiply by 3. You cube it. So I got 2x minus 3 equals 3 cubed, which is 27. Add the 3. 2x equals 30. Divide by 2. X equals 15. Very good. Does that make sense, gentlemen? Promise? Yeah, very simple, right? Very, very simple. Good, good, good. May I continue, gentlemen? Awesome. Thank you, gentlemen. Now, procedures for solving equations with 2 radicals. Sometimes you're going to have 2 radicals. First of all, you're going to isolate one of the radicals. Okay? Get one of them alone. The other one may also be alone. It may be attached to something else. Number 2, cancel out or eliminate the radicals by raising both sides of the equation to the power of the index, same as before. And then 3, solve the resulting equation and check for extraneous solutions. Okay, before we get to this, I'm going to tell you right now, this is going to get a little bit crazy, all right? And you guys got to remember how to multiply perfect sums of squares. You should really know your difference of squares. And if you don't know that, this is going to be increasingly more difficult. If you do know that, this is going to be a cakewalk. It's going to be a joke. So it really depends on you and how prepared you are. Okay. Number 1, we got the cube root of x squared minus 4x minus 2 equals the cube root of negative 3x plus 2. How do I cancel out that radical, that third index of the radical? You cube both sides. Very good. So when you cube both sides, you're going to get x squared minus 4x minus 2 equals negative 3x plus 2. Now, how would I solve this? Sir?
You add the 3x and subtract the 2 to the left.
Very good. You're going to create a trinomial. Very good. This is just what we just finished a long time on, guys. We worked on quadratic functions. For a long time, I broke it down for you very clearly. We did graphing. We learned how to solve by factoring, completing the square, quadratic formula, discriminant, what the solutions were, what the end behavior was. We talked everything there was to talk about quadratics. Now you're going to have to apply that knowledge. So you're going to have to create a trinomial here. So you're going to add 3x and subtract 2 just as my boy told me. And I have now x squared minus x minus 4 equals 0. Now, here comes the fun part. You cannot factor that. Very good, guys. You cannot factor that. So I'm going to have to use the quadratic formula. So give me 1 second right quick, though. Please be careful and please always remember to label things. My A equals 1 here. My B is negative 1. And my C is negative 4. So I have negative B plus or minus square root of B squared minus 4 times A times C. All of that over 2A. So that equals 1 plus or minus the square root of 1 plus 16 is square root of 17 over 2. And bada bing, bada boom, those are my 2 answers. Okay? And just so you know, when it's cubed, checking, you don't really even have to worry about it because you know that none of them are going to be negative, and if they are negative, it's still the same because it's a cube root, it's legal. So that's all good. Now, for B, we're going to get a little sticky here. For B, I first have to isolate one of the radicals. So me personally, I like working with positive things. So I'm going to add square root of x plus 6 to both sides. This is going to give me the square root of 3x plus 6 equals 2 plus the square root of x plus 6. How do I cancel out that radical of 3x plus 6? You square both sides. Very good, my brothers. So this is going to give me, that cancels, 3x plus 6 equals 2 plus the square root of x plus 6 squared. Before we get to this, let me just drop this down. Because we're going to need a lot of space. Okay, now, when we square 2 plus square root of x plus 6, the answer is 4 plus x plus 6, right? Right? Wrong! I got you all. Guys, how many times have I told you this? I know it's Friday, but come on, y'all. This is 2 plus square root of x plus 6 times 2 plus square root of x plus 6. Now, you want to FOIL that? Good luck. Have fun with it. You can. There's not a problem. You can absolutely FOIL that. But man, is it going to be a lot easier if you just go ahead and know how to multiply sums of perfect squares. Give me 1 second, please. Okay, so the accurate way to do this, the quick and efficient way rather, is to know your formula. So this is going to become 3x plus 6 equals. It's the first term squared plus 2 times the first times the second, which is 4, square root of x plus 6, plus the second term squared, which is x plus 6. It's so much easier that way. So much easier that way. But if you don't want to do it that way, don't do it that way. Do it the long way. The long way is going to be, we'll do it in red. 2 times 2 is 4. Plus 2 times square root of x plus 6 is 2 square root of x plus 6. Plus 2 times square root of x plus 6, which is 2 times square root of x plus 6. Plus square root of x plus 6 times square root of x plus 6, which is x plus 6. Which then is 4 plus 4 square root of x plus 6 plus x plus 6. You want to do it that way? Be my guest. There's nothing wrong with that. I want that to be clear. Not a darn thing wrong with that. But why would you go through that mission? We've already been talking about the format of the perfect square binomials and difference of squares for like 3 or 4 months already. Learn it. It's going to behoove you. Now, let's go back to where we were. Okay, so now I have 3x plus 6 equals 10 plus x plus 4 square root of x plus 6. Now I'm going to subtract the 10 and subtract an x to both sides. So that's going to give me over here 2x minus 4 equals 4 times square root of x plus 6. I'm going to chill for 2 seconds. Make sure that everyone sees that. Make sure that everyone understands what I did, why I did it. And if you don't, if I've lost you along the way, simply talk to me and I will help you with anything you need. Questions? Yes, sir, my brother. In the beginning, I did square the problem, son. I had to move this over. As per the rules of this lesson, you have to isolate one of the radicals. Because if you want to actually square this, it's virtually impossible. Because what's going to happen here is, even if you do the perfect square formula, first term square would be 3x plus 6. Cool. But how are you going to do 2 times the first times the second? Multiplying square root of 3x plus 6 times x plus 6 gets into a nasty, nasty radical. So that's why you follow the directions. That's why we have procedures to make your life easier. So you isolate the radical first. Thank you, sir. You're welcome, sir. God bless you. Now, how do we solve for x here? No, you don't want to divide by 4 yet because you're going to square something. And when you square something, you don't want to have to deal with fractions. So I'm going to square both sides. And this becomes 4x squared, because first term squared, plus 2 times the first times the second, or minus 2 times the first times the second, negative 16x, great, plus 16 equals 16 times x plus 6. Guys, are you seeing how insane this problem is? I hope you guys are keeping up because I'm going to put a lot of these on the quiz and a lot of these on the test. Well, you guys are juniors. We're almost at the end of the year. You're going to be seniors next year. You're worth it. You can do it. I believe in you. So now, I've got 4x squared minus 16x plus 16 equals 16x plus 96. Subtract the 16x, subtract the 96. So subtract 16x to both sides, subtract 96. You've got 4x squared minus 32x minus 80 equals 0. Divide both sides by exactly what you said, 4. Good job, whoever said that. I'm very proud of you. Now you got x squared minus 8x minus, what is that, 16? No, wait. No, that's 20. What's wrong with me? That's 20 equals 0. Now, luckily, you can factor this. Luckily. What times what is negative 20, but when added together is negative 8? Negative 10, positive 2. So x equals 10 or negative 2. And those are my tentative solutions. I now have to go back and test it. Hey guys, I didn't invent this math. I'm just teaching it.
You're doing a great job, sir.
Oh, thanks a lot. No worries. Okay. Now, let's plug it in and check it out. No, guys, this is not rocket science. This is math. It's just easy. So let's check when x is 10. When x is 10, what's 3 times 10?
30.
Plus 6?
36.
So that's square root of 36 is 6. And then what's 10 plus 6? 16. What's square root of 16? 4. What's 6 minus 4? Yeah, that works. And then negative 2. What's 3 times negative 2?
Negative 6.
Negative 6 plus 6?
0.
Square root of 0?
0.
Okay, so we got 0 there. And then what is, negative 2. What's negative 2 plus 6? 4. What's square root of 4? 2. What's 0 minus 2? Oh, that doesn't work. So this guy here is extraneous. Guys, please. The negativity is not going to help you guys. Okay? So let's just realize that we have to do this. It's just the way it goes. I'm sorry, but that's the way it goes. Okay, guys? Now, let's do C. Okay. Okay, no. First thing you want to do, sir, is add square root of x plus 4. It does not matter which one. I like to choose the negative radical to move over because I like to keep things as a positive. Correct, sir. Thank you. That's exactly correct, my brother. You're going to square both sides. Awesome. So this cancels, and I've got 2x plus 1. And now you see why you don't want to do the long way for this. Because this is already a long and tedious procedure. I get it, guys. I get the negativity. I understand why. But let's turn it around. Let's just realize that this is what we have to do in this section. That's it. Complaining about it isn't going to help us, okay, my brothers? So just relax. Take your time with this. You can and will succeed. I believe in you. So when I go ahead and square a perfect square binomial, it's the first term squared, which is 1. Okay, boys. So first term squared is 1, because 1 times 1 is 1. Plus, what's the first term squared? What's the first term times 2 times the second term? 2 square root of x plus 4. Good job, gentlemen. Plus the second term squared. X plus 4. Beautiful. Well done. So this is 2x plus 1 equals 5 plus x plus 2 square root of x plus 4. Subtract the 5, subtract the x, subtract the 5, subtract the x, And you get x minus 4. Thank you. Good job, brother. Those cancel. And I got 2 times the square root of x plus 4. Now, I got to square both sides. Very good, my brother. I got to square both sides because I got to get rid of that radical. So here I have another perfect square binomial. So this is the first term squared minus 8x, because it's 2 times the first times the second. Great. Plus 16. Excellent. Equals 4 times x plus 4. This is x squared minus 8x plus 16 equals 4x plus 16. These 16s cancel. I subtract 4x to both sides, my brothers. And I get x squared minus 12x equals 0. Excellent. Now what do I have to do here? What can I factor out of here? Excellent, brothers. I can factor out an x, giving me x times x minus 12. 0 product property. X equals 0 or positive 12. Now, again, brothers, I know it's tough, but unfortunately I got to check that. So I checked 0 and 12. There may be people writing that, so let me just clone it. And that way I can check it down here while you guys are still writing. And that way no one will fall behind. Okay, now, when x is 0, what's 0 times 2? 0. What's 0 plus 1? What's the square root of 1? 1. Minus. What's 0 plus 4? The square root of 4? 2. Is 1 minus 2 equal to 1, my brothers? 0 does not work, because that does not equal. Okay? Now, let's try when x is 12, my brothers. What is 12 times 2? Plus 1. Square root of 25. Minus. What's 12 plus 4? And square root of 16? What's 5 minus 4? 1. And that works. Okay, guys. Now, last one. Oh, yeah, there's more. Yeah, I know. I know. It's hard, guys. I know. It's really not that bad. It is a long procedure. I get it. And it's intimidating. I get it. But you can and will succeed if you so choose to succeed. Remember, guys, life is about options. It's about choices. And I pray that you make the right choice and not look at this so negatively. Okay? Let's do this again. Excellent start. The radicals are already by themselves, so I'm going to cube both sides. The hardest ones, guys, are when you have a radical and a whole number. Those last two examples that I gave you, you got to admit, this whole lesson has been pretty easy. Those are the hardest ones. So the good news, my brothers, that's as hard as it's going to get. That's as difficult as it's going to get. Everything else is pretty simple, in my opinion. So you cube both of these. Excellent. So I've got w squared plus 4w plus 4 equals 2w plus 7. So now I just subtract 2w and subtract 7 to both sides. That's exactly correct. And I've got w squared plus 2w minus 3, great job, son, equals 0. See? Don't make a mountain out of a molehill, guys. This is going to be negative 3 and positive, no, positive 3 and negative 1. Thank you. Equals 0. So w, using the 0 product property, equals negative 3 and 1. Now let's see if it works. What's negative 3 squared? Positive 9. Positive 9 minus 12 is negative 3. Negative 3 plus 4 is 1. What's the cube root of 1? 1. Does that equal? 2 times negative 3 is? Negative 6 plus 7 is? Cube root of 1 is? It works. How about for 1? What's 1 squared? 1 plus 4 is? Huh? 1 plus 4 is? 5. 5 plus 4 is, so I have the cube root of 9 on one side, because I cannot simplify that. What's 2 times 1? 2. And 2 plus 7 is, does the cube root of 9 equal the cube root of 9? Okay, I had a question. Can't you simplify the cube root of 9? No, because 9 is 3 times 3. In order to simplify that, I would need 3 3's to pull out a 3 from an index of 3. But thank you for caring, my brother. I do appreciate that. So guys, if I were you, I'd really focus and watch this again to make sure you got the procedures. Yes, sir, because we're not done yet. Yes, sir.
I don't know if you're going to get to this or not, but what if, I don't know if it's even possible, but what if they had different indexes?
That is a wonderful question, son. It's actually a great question. The question was, what if I have the square root, we'll just make it easy, x plus 5 equals the cube root, of whatever, 2x minus 3. Okay. In this particular case, guys, this gets a little bit weird. You could go ahead and square both sides. This will cancel. You got x plus 5. But now this, I can't cancel this. Okay? This is going to be 2x minus 3 to the negative 2/3 power. So you could go 2x, well, yeah, okay. 2x minus 3 to the 2/3 power. Now if you multiply by the reciprocal though, now we're going to keep going back and forth, right? So now if I multiply by 3 over 2, okay, we'll multiply this by 3 over 2. So now this is the square root of x plus 5 cubed equals 2x minus 3. How many times can I take, how many x plus 5s can I take out of here? No, you can take 1. 2 goes into 3 one time. So I'd have x plus 5 times now the square root of x plus 5, which equals 2x minus 3. Now, I could solve this by squaring both sides, which I'm not going to do, because it's going to get pretty ugly. Okay? But now I can square both sides, and I will eventually find an answer. But it's going to be a very long question. So the answer to your question is yes, you can. It's going to be very long and very tedious. Not the norm. But you can, yes. Yes, sir.
If you remember that situation, just go back to the beginning of the problem. Would you be able to multiply all those by the exponent of 6? Cancel.
Yes, that's brilliant. That's another way to do that, which is fantastic. Since you could do this. It's quite brilliant, son. It's 1 to the 1/2. This is 2x minus 3 to the 1/3. What if I raise everything to the 6th power? Now I got x plus 5 cubed equals 2x minus 3 squared. It's going to be equally ugly, but yes, you can get to it. You get through it. And for this, you're going to have to use the rational roots theorem. It's going to get really nasty. But the answer to your question is yes, you can. Okay. Thank you, my brother. Great question. Oh, thank you. Okay, now, last one. The formula for finding the margin of error when estimating population mean is given by E equals Z times, that's a sigma, over the square root of n. E is the margin of error, sigma measure is the measure of variability, and Z is the measure of relative position. I want to A, solve this equation for n, which is the sample size, and then I want you to find n when I give you these values to plug in. So this part is easy. I've got E equals Z times sigma over square root of n. Okay? I want to get n alone, but n's in the denominator. So what's the first thing you think I would do? How do I bring it to the numerator, my brother? It's great.
You multiply both sides by the square root of n.
Excellent. You're going to multiply both sides by square root of n. So this gives you square root of n times e equals z times sigma. Okay, I know it looks like a 6. I'm sorry. Now, how do I solve for n? Divide by e to both sides. And then the square root of n equals z times sigma over e. And then how do I solve for n? Square both sides. That's square root of n. I need to solve for n. So n equals z times sigma over e squared. And now, how do I find n? I literally just plug it in. N is going to equal z, which is 2, times 12, which is sigma, divided by e, which is 3. All of that squared. 2 times 12 is 24. Divided by 3 is 8. 8 squared is 64. Very good, brothers. And that's my answer. Okay? Yes, sir, my brother. Yeah, that's exactly right. This was just manipulating and knowing how to get rid of that radical. If you don't know the skill to get rid of the radical by multiplying it to the power of the index, it gets really tough, almost impossible. Last but not least, in this particular case, the period of a pendulum is the time it takes to complete one trip back and forth. The period t in seconds of a pendulum of length L in feet may be approximated using the formula t equals 2 pi times the square root of L over 32. Solve the equation for L. Okay, what's the first thing you think I want to do here? No, this isn't a square root, so I got to get rid of that square root. Okay, I'm going to square both sides. Very good. So I'm going to get t squared equals 4 pi squared times L over 32. Okay? I'm going to go ahead and simplify this. This is t squared equals pi squared L over 8, because 4 and 32, I could divide 32. Now, I'm going to get the L alone by multiplying by the reciprocal of pi over 2. Okay? So L will equal 8 times t squared over pi squared. And that is exactly what I'm looking for. That is my L. Now, how do I determine the length of the pendulum whose period is 2 pi? I said the period was t, so L equals 8 times t, which is 2 pi, squared over pi squared. L equals 8 times 4 pi squared over pi squared. The pi squareds cancel. 8 times 4 is 32, and L equals 32. My brothers, I mean this from the bottom of my heart. I know that this was a very long procedural lesson, but you have to believe me when I say that I believe in you. I know you can do it. Don't let this scare you. You are strong, you are smart, and you can do this. I hope you learned a lot. I know it was crazy. Watch it again. God bless you all and have a wonderful day. Thank you.